that's because you got here two bar graphs. They make the, oh, come on, man. They make the L's. And then this O here, where you're identifying the objects that are in the system. Okay? So we went through the first example here. One thing I didn't talk about on Friday that could come into play today. So let's say we think this thing's a little bit slower than 1 block worth of EK. Let's say it's just creeping along. If I want to draw a half block, you don't want to draw like a stubby toenail like that because somebody might just think that's a whole block. So if I'm trying to show somebody this is half a block, I'm going to make half a block be a triangle like that, and then I could have the other half a block up here. And now when I add these together, I've got half, 1.5, 2.5, 3, 4. I've got 4 blocks, okay? So something to be aware of. Half blocks should be drawn like that. All right. The last one we had here, the situation is the same as problem 1A, except the final position of the cart is lower on the track. Make sure bars are scaled consistently between problem 1 and 4. System consists of the cart, earth, track, and spring. So I'm going to identify those in here. Cart, earth, track, spring. So if you go back and look at part 1A, I've got 4 blocks of EE. So I want to have 4 blocks of EE down here. No EK, it's not moving at position A. No EG, it's at its lowest position there. And then we move on to position B. And so the difference here is position B is not as high up the thing. So I've been calling position B at the top of the loop 2 blocks. Position B that's only halfway up the loop, I'm only going to give that 1 block. This is the same as problem 1A. And problem 1A was frictionless. So I'm not going to have any E-dis here. The spring's not involved, so I'm not going to have any of that. I'm going to have 3 blocks of EK. It's going faster at that position than it will be when it gets to the top of the thing. So I've got E at position A equals EK at position B plus EG at position B. All right. All right. So that leaves you with what? 2A, 2B, 3A, 3B, 4A, 4B, 4C, 5A, 5B, 6A, 6B. Okay. So there's quite a few remaining here for you. What I'd like you to do is work through them with your group mates, kind of work together on it so you guys can answer questions as you work through, see if there are any that are kind of contentious, where there's disagreements on how to represent it. Remember that the number of blocks is kind of your arbitrary choice, but you need to have conservation. However many blocks you have in the system, you need to be able to account for those throughout the whole process, okay? So I'm going to shut up and let you get on with the show here.